Hello there, I'm Thomas Hatsios, the pilot captain flying the Boeing 777-300 ERX in tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, and then coming back to Switzerland and Zurich and Zurich International Airport, runway 14 via the 38 airport. So right now I'm in the cockpit for the pre-takeoff preparation of the Boeing 777-300 ERX of the PMDG simulations. So I'm gonna show you the cockpit instruments, things like the primary flight display with the airspeed indicated and the airspeed selected from the autopilot and flight director system panel, with the barometric altitude above sea level and the altitude selected from the autopilot and flight director system panel. The speed guidance and flight guidance of the autopilot and flight director with the horizontal pitch indicator and the pitch ladder and the bank angle in degrees. So I'm gonna show you also the radio altitude above this ground level. That's in the primary flight display. The magnetic through heading, the flight mode annunciator with the auto thrust, auto throttle and autopilot system commands for vertical and lateral navigation. I'm gonna show you the navigation display with the airports, the GPS position, the terrain data from the radar, the waypoints, the navigation like the VOR stations and the ADS, CNDBs, the waypoints for the flight plan and flight path of the aircraft that we're going to be creating using the flight management computer. I'm also going to be showing you the magnetic through heading, the wind speed direction and the ground speed of the aircraft, and also the navigation of the aircraft using the navigation display in the flight management computer and flying manually with the autopilot and auto thrust. So I'm going to show you also the autopilot panel with the autopilot engage and disengage switch, the auto throttle left and right engage and disengage switch, the head, the speed guidance, the speed select knob and switch, and also the flight level change modes, the glide mode, the N1 mode, the lateral and vertical navigation, the LNAV and VNAV of the flight management computer input, and also the heading select, the bank angle limit for the autopilot and the heading select knob, and also the heading hold switch. So we also have the vertical speed guidance with a vertical speed in hundreds and thousands of feet per minute, or in flight path angle, the FPA, in degrees, in angle degrees, radians degrees, like 2 or 3 degrees climb or descent. So we also have the altitude hold, the altitude knob select switch for this autopilot and flight director system panel. We also have the ACAS, the upper and lower ACAS, the engine indication and crew alert system with N1 display, which is a low speed, low pressure compressor stage display of the engine, the exhaust gas temperature of the engine, the flap setting, the duct pressure from the high pressure engine stage into the cabin pressurization system through the pack, the outflow valves, and also the fuel quantity in thousands of kilograms, some other information like warnings with yellow letters, these warnings. And we also have the lower engine indication and QRS system with the engine also display the N2, which is the high pressure, high rotor, high speed rotor stage of the engine, the oil quantity, the oil temperature, the fuel flow in thousands of kilograms per engine per hour, and also the vibration of the N2 stage of the engine. So we will have also other systems displayed in the lower ACAS, which we have also in the overhead panel. Things like the electrical, the left and the right engine, integrated drive generators, electromagnetic generators that produce 115 volts, 400 Hz frequency, alternating current. 3-phase alternating current, 115 volts, 100 Hz frequency, 75,000 usually kilovolts or 75,000 watts. for its left and right engine, 150,000 total. And plus we have the auxiliary power unit, plus 75,000 kilovolts, so 115 volts, 400 shares, frequency, three-phase alternating current. So all this is used to energize the aircraft system, and also to start the engines in the ground or in the air using the APU. We need some current, so all this alternate current, some of that can be converted into direct current using the transformer rectifier, and charge the batteries, for instance, the primary battery in this APU battery, and also supply other direct current needs. So we also have the batteries which supply with direct current 88 volts, 47 ampere hours, the primary and the APU, and this current can also be converted into alternate current using static inverters. So So we also have the backup generators for the alternate current, electromagnetic current generators of the engine, backup. And also we have the hydraulic power pumps from the left and right engines, the engine driven pumps, electromagnetic driven for electric current, and also we have hydraulic pumps for the hydraulic fluid used for supplying the flight controls, things like the stabilizer trim, manual and automatic electric trim. It needs to be actuated hydraulically. We have the elevators position, the horizontal stabilizer, horizontal tail of the elevators, the vertical stabilizer rudder, the rudder, also needs hydraulic power from the left and the right engine. For the APU, we also have other things to supply, like the spoilers, the left and right wing spoilers of the aircraft, the flaps and the slats, which create additional lift to the aircraft wings, the ailerons and the spoilers and the flaperons, which are used to turn the aircraft in flight. So I'm going to be explaining this. The flight controls use supplied from the hydraulic fluid tank, which is pressurized by the engines when the engines are working, or from the backup C1 and C2 generators. So we also have other things like the landing gear extend and retract, the normal and alternate braking, the flaps and slats position, normal and alternate. We also have the nose wheel steering and the landing gear, as I said, extend and retract, and the thrust reversers from the engine thrust lever. So we also have the speed brake, and this is most of the system using hydraulic fluid, and we also have the primary flight computers. This fly-by-wire aircraft. In the overhead panel we have the ADIRU, the Air Data Inertial Reference Unit, which is used to supply with air data inertial navigation, gyroscopic acceleration and deceleration. We have laser gyroscopes, 2 or 3 GPSs for positioning the aircraft, and also magnetic compass, and air data from the pitot static for the barometric altitude, and the pitot anemometric for the airspeed of the aircraft, and also the angle of attack of the aircraft using the angle of attack sensors. All these are fed into the, we also have the radio output. So these are fed in the primary flight display, the navigation display, the autopilot and the auto thrust, the upper and the lower ECA, the flight management computer, and other systems. So the flight control computers, perhaps. We also have on the overhead panel the electronic engine control computers for the engine, left and right, normal and alternate function, and with the auto start switch and auto start selector on and off. This controls the FADEX, the full authority digital engine control computers, which control and monitor all the engine functions that you see displayed in the ACAS, in the education controller system, like the N1, the N2, the exhaust gas temperature, the oil quantity, the fuel flow to the engines, the vibrations, other functions. Uh, So we also have on the overhead panel the wing and engine RDIs. We have the cabin pressurization manual and automatic with the outflow valve, which admits compressed air from the engines or the APU to compress the aircraft cabin as the aircraft climbs, or to decompress it as the aircraft descends. So in many ways, cabin pressurization differential with the outside environment, with the air atmosphere. So, and we use the outflow valves to open and close to pressurize or depressurize the aircraft. So we also have the electronic. We have uh, the compressed air management panel, the ECS. So. Which is used to control the aircraft compressor from the left and the right engine, and the APU, which is used for cabin pressurization, for pressurizing hydraulic fluid, and also the hydraulic fluid tank, and also for wing and engine RDI, and for the cabin air conditioning and ventilation. So I believe we have like now maybe yeah, perhaps more than 1 hour for this flight. So I'm gonna be very brief. I'm gonna start showing you the flight controls of this aircraft. Thank you very much one more time for watching. I'm Thomas Hatsios, the pilot captain flying the Boeing 777-300 ERX in this flight. So you can see here we have the flight controls. The elevator moving up and down, the control column, and the ailerons and the spoilers using, and also the flapper is using the control wheel. So you will see now having this. You will see now having this side stick here to control the aircraft flight controls in flight, pitching up and pitching down the elevator, mangrove, left and right, the ailerons, the spoilers, and flaperons. Will control the aircraft around its longitudinal axis, pitch up and pitch down around its lateral axis, and the rudder pedals around its vertical axis. So we also have the thrust levers and the pitch trim position stabilizer trim of the horizontal tail. So you can see this here. We have proportional movement. We also have this, for instance, this display here in the lower. The flight controls. You can see the position. We can extend the speed brake. You will see all turning white, and also moving left the aircraft, moving right the aircraft, pitching up and pitching down, and also the rudder here. You can see displayed. The stabilizer trim and the rudder trim position. You can see the engines of the aeroplane, the Boeing 777. You can see here in the control column and control wheel have the stabilizer trim switch here to pitch up and pitch down the aircraft. We have the autopilot disconnect. We have the aileron trim here. We have the parking brakes here. You can see it's important. The parking brake here is the stabilizer trim position. The horizontal tail of the aircraft. So you can use also this normal, the alternate pitch trim. You can see alternate here to position this here the horizontal tail of the aircraft position with respect to the airflow. So you can see there is a proportionality of the movement of the flight controls, control column and wheel, the yoke of the Boeing 777-300 ERX aircraft. With this side stick I'm having here, there is a proportional movement. analogous to the side stick position. As you can see, pitching up, bang rolling, left and right, rudder pedals, stabilizer trim and thrust levers. So you can also see it here when I move pitch up and pitch down the aircraft and bang roll left and right. There is no difference. Also, this is an Airbus side stick. So I'm gonna show you now outside the flight controls of the aircraft. You can see it here, the Boeing 777. You can see the elevator, the horizontal tail of the aircraft, and the rudder, the vertical tail. The rudder function, the ailerons and the flaperons, and also the spoilers. Turning left, then turning right this way, turning left again. This causes an aerodynamic pressure change between the left and the right wing, or the tail of the aircraft, or the vertical stabilizer. That is creating aerodynamic aerodynamic change that is creating a center gravity moment turn. So it's causing the aircraft to turn pitch up and down or bang roll left and right for you. So you can see again with the side stick we have the correct elevator and ailerons and spoilers movement, pitch up, pitch down, bang roll left and right, control column pitch up and pitch down, and yoke and control wheel turn left and right, and also the rudder pedals. So this function, the stabilizer trim, you can see all this working normally, and in proportion with the side stick position here, all this movement. So we have full control of the aircraft here, as you can see. So this is all the flight controls of the Boeing 777-300 ERX. Gonna come now inside and show you the rest of the aircraft. I'm gonna come now inside and show you how to make the engine start demonstration, show you some of the systems, and set up the flight management computer, flight plan, and fly the aircraft. So I'm coming inside now. So I'm gonna show you now all these things. Thank you very much for staying with me. So we have about an hour left for this flight, so have to be more swift. So we have here the primary flight display with the airspeed display. The ground speed is 0 right now. The barometric altitude above sea level, and the radio altitude, the magnetic and true heading. We're gonna have the ILS in a while. This is the airspeed selected and the altitude selected. Display magenta, the takeoff plan, flight director. You can see here the pitch symbol for takeoff, how many degrees we should rotate the aircraft for not having a tail strike. So this is the airports, some of the airports around us. You're gonna see we have the terrain 6,100 with red and 0 feet with green. The elevation. We also have track here, magnetic track. We have ground speed 0. Later you're gonna see more information. We have the aircraft symbol and the range. These are arc symbols. We have the standby instrument here, the flight management computer, lower ACAS, the upper ACAS. You can see here we change the autopilot and flight director here. We would change the airspeed here. And this is also the pressable. This switch is the pressable inside. This also change the heading. to the runway we're gonna use for takeoff. So 136 degrees, the autopilot, flight director, you can see on and off, flight director off, flight director on. If I turn to the left of the auto throttle, you can see the message here on the right. So we have the altitude select here, gonna change it. The flight altitude, we have the vertical speed, flight path angle here, negative or positive for climb, negative for descent. We also have the flight path angle in degrees. Like 2 or 3 degrees of climb, you can see. Also these switches are depressible here. You can depress in to select this value. We have the bank angle limit here, we can change this to a different value, but we'll leave it in the auto. Also the altitude, whether we wanted 1000 of feet or hundreds of feet, also the airspeed here. So we would connect the autopilot here. You will see the autopilot is connected now. We can disengage the autopilot if we want, using this switch here. The autopilot disengage. You will see the warning here. We turn this back on. We have the autopilot now, flight director is on in the warning. So this is the FE, some other information for the map here, the navigation display. Maybe we have like about 52 minutes left for this flight, so I have to be brief. So this is the N1, which is the low pressure, low speed starter stage of the turbofan turbojet engine. The exhaust gas temperature, the flap setting. We can use a higher flap setting here for this takeoff. We need like 15 degrees of flaps. You will see the flaps position moving here to the 15 from the full 30 now. The landing gear is down. You can see the symbol, gear down. So you see the landing gear here. This lever, we have some auto brakes, alternate gear and normal. You can select either alternate gear or normal. So you can see the extend speed, the auto brake system here, the flap override, some other functions also later. So we have so you see here some of the engine functions. So, we have the modes here. We have the engines, also the rest of the engine. We have the M2, which is the high pressure, high rotor stage of the turbofan turbojet engine. The fuel flow, 1000 kilograms per engine per hour. The oil pressure, oil temperature, oil quantity, and the vibration of the engines. So if I move the engine thrust levers forward, you will see the engine thrust increase rapidly. And moving to the target value, to the TLA thrust lever angle, commanded position manually. So now it's 95% N1, about 90% N2. Fuel flow goes to about 5,000-6,000 kilograms per engine per hour. So you can calculate based on your total fuel here, how many hours of flight you have based on your thrust position. You have the dark pressure from the engine, again increasing. The cabin altitude is the pressurization system. It's automatic now. You can see the differential pressure and the outflow valves open or close. This is some of the information. You can see also here the barometric altitude pressure for the barometric altitude and perhaps the airspeed. Airspeed may be corrected, airspeed. So I will show you some more modes now. We have the status here. You can see the hydraulic pressure, the oxygen, and the APU right now is off. So the APU is up here in this panel. I'm gonna show you also this view. The overhead upper panel view. You can see here the cockpit again of the Boeing 777. So we can start the APU here, which is the auxiliary power unit. This is the electrical panel. You can see we have the battery, primary and standby. You can turn off the batteries here. You will see the message here, battery off. Maybe. Yeah. Here, it's not causing any problems, so it's not displayed. You don't need the battery. But if we lose the engine, we're gonna need the battery. We're gonna have a full mess. So you can see also the left and the right engine is the great drive generators, electrical, the backup generators, 115 volts, 400 Hz frequency, 75,000 kilovolts, three-phase alternate current, direct current from the batteries. I'm going to show you the systems in the other display. We have the hydraulic here, the pumps, the passenger signs. You can see the ADIRU, the data inertial reference unit. We have the primary flight computers here. The ADIRU we can turn on and off. If we turn off the ADIRU, there is no air data and there is no GPS position and gyroscopic acceleration. Most of this information is lost. So we're gonna make an alignment now. You can also turn off this with the great drive generators. You can see TICA, SATCOM data link is lost. So Northern. We connect this with the great drive generators, the alternate current. So we lost the RS position now. No GPS, no data link with the satellite. You can see. So need to reposition the aircraft. Using the GPS, set inertial position. Here is gonna to align itself and using the reference airport Lszh. So you will see we have back this reference position. So we can go now into the other displays. If I do that again, you will see better what I mean. I can turn on and off this. We're gonna lose the alignment. So you can set the position, set inertial position. Oh, here we have it. Now we need to realign ourselves again. So it's going to alignment again. Set. Let's see it. Set this position. Perhaps we're gonna have it instantly. like in a couple of seconds. 4, 3, 2, 1. And here it comes. We have both displays and the radar also. Radar scan again. So this is the normal for this the Adiru. We have the electrical that I saw you. The APU now is running. We have the hydraulics here. You can see the hydraulic. You can turn on and off the hydraulic pumps here. So you will see here the APU now is running full, 100%. We're losing the hydraulics now. So the display, we have the engine, we have the status, synoptics. I'll show you the electrical. You can see the left and the right engine, the electrical here. Now we're losing some of the hydraulics. So we go back into the hydraulic here page. You can see the left and the right engine is 0, no hydraulic fluid. So we come here, we have the backup in the overhead upper panel. We lost the left and the right engine. We still have the backup, but we turn on. You can turn off the backup if you want. You see, we have the opposite now for the hydraulic fluid. So we're gonna lose the backup now, but we have the left and right engine running 3000. This side is hydraulic fluid, so we have some alternate slots and flats here maybe. So going back on the overhead panel. So we turn this back to the on. This is the hydraulic, this is the electrical that I show you. You can see the backup generators also on and off. Drive disconnect. We have the APU on, the primary flight computers here on and off. The fire extinguishers for the cargo, the window heat, the rammer turbine. So this is the most of the Boeing 777. You can see the overhead panel. We also have, you can see electronic engine control computers for the engines, normal and alternate. With the auto start on and off here. You can see the arm for fuel jettison. We can dump some fuel in flight. And also you can see the X feed for this is the fuel tanks, left wing, right wing, and center tanks, and the forward and aft pumps. So we turn off all the pumps. For instance, I come here. In the virtual cockpit, you're gonna see the fuel. Here we have the fuel jettison arm to remain. How much fuel to remain? Minimum temperature. Fuel temperature. We have the engines here. Left and right engine. Total fuel kilograms. Only the one pump is working. Here is the line for dumping fuel. You see, but you can see it. So we go back in the overhead panel upper. We connect this, all the pumps, and also disarm this, the fuel dump. We don't need this. So we come here. Now we have the normal mode for the left and the right wing, a fuel tanks, the total fuel, the engine's fuel flow, low and high pressure valves, 46,700 kilograms. The APU also feed. You see the green line is feeding, the white line is not feeding. So we have the electric that I have been showing you. You can see the left and right engine driving, electromagnetic generators, the backup is on but not feeding, only as a backup. We have the main battery and the PU battery volts on the average. The APU is also running and the bus tie switches. So we have the hydraulic, left and right engine, the backup generators. I can see nose gear steering, alternate flaps, normal flaps, rudder, ailerons and spoilers, stabilizer train, nose wheel, steering, nose and gear, and also landing gear external retract, the thrust reversers. So this is fed by these hydraulics here, the other from the electrical page, the fuel over here, the auto start of the engine, the fuel jettison, and here we have the cabin pressurization, the pressurizer. Gonna come now in this section. We have maybe the overhead lower. Need to leave this here. We have the cabin pressurization, automatic, as I explained you, the controllers for the outflow valves in the manual. In the automatic we don't need to control, we don't need landing altitude, automatic. So we have this engine driven compressor, 59 state high pressure. From the engines into the cabin pressurization, when an engine at the ice over here, you can see the RDIs is automatic, and pressurization automatic, and also the hydraulic fluid tanks here, pressurizing air, and also the air conditioning and ventilation of the aircraft. So for starting, maybe the left engine we're gonna use a setup like this using the APU. So if I come here in the virtual cockpit, you're gonna see turn off a few things here from the pressurizer section. So you also see we lose some the air C1 and C2 for the pressurizing the hydraulic fluid tank. You can see the yellow with the, this is a warning. So we have the air system here. You can see we isolated the right engine for starting, the left engine using the APU, but we need to turn off the engines first. So you can see duct pressure to the right engine is 0 and displayed with yellow. Left engine still pressurized, you can see. So if I come here again in the overhead panel, we reconnect the pressurized air. You can see this, the left and the right engine packs. So this is most of the overhead panel. I have, I believe, about 40 minutes left for this flight. So we need to be very brief. You can see the autopilot again section here. I'm gonna show you later, maybe we have time. I saw you already. So we have the thrust levers here, the speed brake that extends automatically, the trim position, the flap lever position, 15 degrees, 20, 25, 30, the fuel cutoff switches, the fire extinguisher, the navigation communication panel, the cyclone with the parking brakes here, the stabilizer trim C and R, for the auto trim and autopilot, the electric trim switch, the flight management computer here, and the ACAS computer display. So you can see all the displays here are normal. We can go to starting, I believe, the engines, because we lost some time with this system. So you can see now we have the pressurizer from the left and right engine from the APU. You can see the stages, the fifth and the ninth stage with the valves, the duct pressure. If I increase the thrust lever position, the engine thrust, there is also more pressurizer. So the duct pressure increasing. So you can see also the air conditioning. So we can use this pressurizer from the APU to compress the engine start during engine start. So we go back to the modes. We have one more. We have the communications here mode with the air traffic control. We have the checklist here, normal menu before start, before taxi we need to do. Before start we are now. This is all the items we have to do, and the checklist here is complete. You can see all the items. So we have the normal menu also. We have a failure, for instance APU generator, normal menu, engines and APU here. Let's see, engines, APU. So select this. Engines and APU. We have engine these demands engine fail, let's say right. What we need to do in case we lose an engine in flight? No, not both engines, only one. I restart, maybe I'm attempted. Yes, monitor exhaust gas temperature, engine may accelerate slowly. So this is the items 1, 2, 3. You can see the side, the cascade side here. Number 3, slow acceleration may be correctly interrupted. Airspeed is available in, let's say no. Fuel control run. You can see all the items we need to do. Let's say yes, yes, yes. Going to the 6. So this is the normal menu, as I told you. This is the computer display for the lower ACAS. So we need to start the engines now. We have about 40 minutes left for this flight. Cancel. So not fixed. So we're going to. We have the doors here. I forgot to show you. The doors are closing and the cabin is pressurized. We have the landing gear. You can see the tire pressure and the temperature of the brakes. So we're going to the engines. We're gonna turn off both engines now. Left and right engine. Fuel flow. I'm gonna lose the fuel flow. And it's almost night now. So we lost some time explaining all these things. We have a few more minutes to go. So you can see both engines. Here is the Boeing 777, 300 right engine and left engine, both slow down to the idle. There is no rotation, only a little bit of spinning, small amount of spinning, but it's gonna stop. So you can see the reset in the overhead panel. We have electrical off, the great drive generators, some hydraulic off. So left and right engine here also off, the compressor. So we need only to do the engine restart using the left engine auto start switch. So you're gonna see we're gonna have the N2, the N1 also. Here increases the exhaust gas temperature. The left engine increases. The N2 above 20%. So we have 14 plus 18. Yeah, about 35 minutes left to go. So you can see the N2 increases. Fuel flow is still 0. So we have the left wing engine spinning now. You can see it spinning. So we're gonna use the fuel flow to the run position. So you will see the fuel flow here jump increase rapidly, and also the N2. And we have the engine start here for the left wing engine. Here we go. You can see the engine spinning. So we'll go on the other side engine. We have about 35 minutes left to go for this flight. So we start the other side engine now, using the auto start principle again. We can use also some lighting here, because it's almost night. So if we monitor the display, we see the N2 here, the N1 over here increases for the right wing engine. Exhaust gas temperature, the N2 fuel flow is 0. Okay. So we see here the outside view. You can see we have started the spinning of the right wing engine also. This is the turbofan turbojet engine of this aeroplane, Boeing 777. So we can run the fuel flow into the engine. You can see the fuel flow will jump rapidly from 0.4. Into also the indications, the exhaust gas temperature here. So we have the right wing also, engine spinning here, and the engine is almost completely started. So we can fly the aircraft now. We only need one last step to set up this position. We need only to set up the flight plan. So we have the gross weight, 0 fuel weight, the fuel of the aircraft, total weight 235,000 kilograms with 46,300 kilograms fuel, 5% reserves, flight level 35,000 feet, coast index 100, minus 37 degrees, and center of gravity at cruise, minus 7.5% of the mean aerodynamic force of the aircraft wings, 15 degrees flat, center of gravity 36, with train position 4. We have the route Z8 to Lszh Z8, copy paste, runway 14. So departure here, departure is runway, using this fix, departure fix, and arrival, Lszh 14, using this arrival flight plan, departure and arrival. So we cancel the discontinuity here. We press activate and execute here. So we have all the route data, gross weight, thrust, flaps position, and the V speeds, V1, V rotate, and V2. This is the takeoff speed, 154 knots with this gross weight for this runway. The reference takeoff speed, this flap setting in center of gravity CG 26% of the mean aerodynamic port of the aircraft wing, with the stabilizer trim here, position at 4 degrees up, pitching out the aircraft here. So we disarm the parking brakes and go. You can see we have all normal. So we have 5 and 3, 8 plus. So about 26 minutes left for this flight. So we have to be very brief. I lost too much time explaining all this system. So we use some thrust and this tiller here to steer the aircraft in the ground. This for steering the aircraft in the ground. So the runway is open to us. We can taxi into the runway for takeoff. So align with the Lszh, the center line. Parking brakes one more time. You see, I'm gonna use this flight plan view here. Also, it's nice view here to see outside. We have 25 minutes left for this flight. So this is our runway position for the takeoff. We're almost ready to go. You can see everything is normal, the ILS localizer, the frequency, the barometric pressure, the altitude, the airspeed is 0, airspeed selected. You select higher airspeed here, the flap setting. So we move the thrust levers forward, we increase the engine thrust, and go. You can see the N1 increases, the exhaust gas temperature, the N2, the fuel flow. So we have the data here, the route data. Just the parking brake here and go. So we have 90 knots right now. So V1, we rotate. So you can see we have the pitch up a little bit. Rally gear and track. 500 feet above the ground level. We need to add a little bit more thrust. So we are 1,400 feet above the ground level. You can see the flight line here, the terrain around us. You can increase the rate of climb for this flight and the airspeed. Very speeding right now. So we need to increase the rate of climb here. Get the pilot disconnect message. So this is our position here. Over flying Zurich and Switzerland. Hope you like the 777-300, our aircraft. We have a few more minutes to go for this flight. So we turn into the sunlight and have a better view maybe. Crossing 9,000 feet right now. And we're flying again, as I said, Switzerland right now. We are into the flight plan here. Unbelievable. That is real now. So we need to turn the direct to intercept heading. So now we go direct to the next waypoint. Over here you can see this one 36 knots from miles away. I will fly 11,000 feet. Increase the airspeed. So increase the thrust automatically here. We have like 18 minutes left. For this flight. Not a good score for this flight, so this is our spacecraft for tonight, the Boeing 777-300 ERX, flying high with Mach 0.5 or about 600 kilometers an hour. I'm gonna be overflying the lake one more time. So this is the view from here. 15,000 feet, slow acceleration on the run. Maybe we need to disconnect the auto thrust system. You can see the auto throttle disconnect here. So we're gonna fly with manual throttle setting. A bit more thrust. So you can see this is 18 minutes left. We need like a couple more minutes to climb into the maximum altitude and have some chemtrails. We are climbing 3 more minutes and we have 15 minutes to go back into the airport. So this is overflying the St. Gallen Lake into the Switzerland. You can see the star signs here. We overflying the troposphere of the Earth. We're going up into the stratosphere. So we are approaching the stratosphere of the Earth. You can see the Earth, the atmosphere ways looking differently. So there's more star sign. Hope you like this wing view. The Boeing 777 airliner. This airplane. So we have reached our stall speed margin here. For this altitude we need to hold up a little bit. You can see I'm flying manually right now. No autopilot use. So maybe we track some flaps because we have this problem right now. We have too much flaps here, so we cannot increase the airspeed. We track knots more up to the maybe 5 degrees, from 15 to 1 degree now. So we're gonna have a lot of airspeed. We have like 11 more minutes to go. You can see we overflying Germany now, so we need to start turning the aircraft. We have 14 minutes actually to go. We need to climb up a little bit more. 33,000 maybe. 33,000 feet, so this is okay. We have the chemtrails now and the contrails. That is what I wanted to see. So we overflying the Germany in a while. We're gonna be overflying Germany, Munich region, the Bayern Munich, and the Bavaria. We left Switzerland in the back. It's about 8 nautical miles away in front of us. With this airspeed about 30 minutes. So we're turning back to the Switzerland now, as you can see, the Boeing 777, 34,000 feet. We need to turn back now, as you can see. We have like 12 minutes to go. You can see the airspeed. We'll increase the airspeed maybe more fast. And we track the flap fully. So we reach also the maximum altitude here, 35,000 feet. So we have 12 minutes to go for this flight. We need to be very, very fast, turning back into the airport. So you can see we fly manually. You can see the chemtrails here, 35,000 feet above the earth, about 7,500 meters above the sea level, about 7,000 meters above the ground. With about 900 kilometers an hour right now, 900, 950. So you can see the Boeing 777 aircraft. How fast we go, 950 kilometers an hour, or about 300 meters per second. We're coming back to the airport. Hope you like the Boeing 777, 300 RX engines, it's exhaust from the engines. How high we are, 7,000 meters above the Switzerland, flying with 950 kilometers an hour, or about we need to connect maybe the autopilot now, just to stabilize the aircraft. So a little while to make a few arrangements here. So you can see the autopilot now is connected here. Put this one down to 35,000. So the legs, we fly direct into this one. Waypoint, execute, and also the initial reference, the landing speed here, flap speed. You can see we're gonna use this approach, landing speed. So here we go, 35,000. We're just 40 nautical miles away from the destination, so we might gonna start descending a while. Flying with maximum. We have about 9 minutes left of this flight, so we're gonna be very on the margin of this. So this is our spacecraft for tonight, the Boeing 737-300 I'm your pilot, Thomas Hatsios. Thank you for flying with me. 950 kilometers an hour, 7,000 meters above the sea level. We have the galaxy, we have the chemtrails here. Get closer and closer to the airport. Like 8 more minutes to go. You have to make a huge shortcut. So we use this light path angle maybe. And decrease a little bit the airspeed. So we start descent. Use some speed brakes here. You can see the Mach speed 0.76. So this is about 900 kilometers an hour. So we have 8 minutes left to go. 8 minutes left. So we are okay with that. Still having 5 flights here. High altitude time. You can see we overflying the lake again with the Boeing 737 here. With this aircraft, this airplane. About 8 minutes left to go. We have this beautiful view of the star sign here, the dark skies. As we descend into the airport, these frozen skies, they're very high. So we are 32 nautical miles away. You can see the Mach speed about 750 kilometers, Mach 0.65. We have 7 minutes left to go. There's some aircraft flying here. So we have to make a huge shortcut after this. Hopefully. We're gonna make it. So we have 5 minutes left, 15,000 feet. We're gonna use the approach here. Also decrease the airspeed a little bit. You see the rate of descent right now. Our airspeed. The runway. You have to disconnect maybe the autopilot. We will see how we disconnect the autopilot flying manually. Coming closer into the runway. So this is the river. Have to start turning. Use the speed brakes, use the landing gear now to decelerate us. We have about 4 minutes left for this flight, so we are in a good position for going to London. It will decrease the airspeed a little bit. So we fly with manual airspeed. This is the runway. We have about 4 minutes left. I believe we're gonna make it. So we use some flaps here. Slow us down a little bit. 6,000 feet, a bit higher than we should, but it's okay, we can start turning. You can see where we are. So we start turning the Boeing 777 to the runway heading. We have like 3 or 4 minutes left to go. You see we are flying the river. Just need to align with the runway. We have 3 minutes left for this flight. So we are 3,500 above the ground level. To 70 knots. We have the Lszh localizer on, but we're going for a VFR, visual flying rules running. You can see our cockpit configuration. I believe we're gonna make it. 2 more minutes left to go for this landing. 180 knots, 185. $177 knots. You can see the Lszh localizer here, but I have no time to explain everything. Again, here we are. Just made it. Parking brakes and reverse thrust. Full reverse thrust, as you can see. Here we are. Just made it into the runway. 1-4. I think we have 1 more minute left to go. You can see we landed very normally, very nice. Got to turn on the lights here. So you can see now we have the light. You can see the nose wheel, the landing gear, the tires are normal, and the strut, the metal of the tires, there is no breakage. Everything is level. All the tires and all the nose wheel of the aircraft here. Here's the nose wheel. So you can see it's normal. We can still control the aircraft. So here we are on runway 14. The Boeing 777 just landed. It's about 170 knots. about 270, 280 kilometers an hour, so the car speed limit. You can see this rudder reverse being engaged here. We can disarm it now.